So normal.pr means part modeling. Normal.psm means sheet metal. PWD means welding. DFT means drafting, symbol draft. Okay. So and last one is weldment assembly. So these are the environments we used to have. So in this we have to select normal.par and give OK. So we'll come to a new window. So once again take up sketch. You can select any of the planes in the edge bar also, or directly you can select any profile or plane, sorry. So I'll take a front plane. Simply I'll draw one rectangle. Okay, I want to revolve this rectangle. So for any revolve, I should have an axis. So that axis should be vertical or any edge of the drawn profile. See, I'll go to revolve protrusion, select from sketch as usual, select, right click to accept. See, next it will ask for axis of revolve. So any of the edges I can select as an axis of revolve. So if I take up this as an axis of revolve, see here, if I press this one, 360, or I can give an angle here. See, for a angle of 225 degree, I revolved my protrusion. So this is with respect to protrusion. Similarly, if you want to do any cutouts, once we have protrusions, we have cutouts. Okay, see here, revolve cutout, swept cutout, lofted cutout, and helical cutout. Right. So for cutout also we should have a profile. Say I'll show one cutout profile for you. Sketch. I'll take up sketch. Once again, I'll take up the front plane. See, for this, what I'll do, I'll draw one circle and this as my axis of revolve. I'll make that line as dotted line or axis line. I'll select that line. This is a different types of lines. Okay, I'll make it as an axis line and I'll return. See what happens. Revolve cutout, select profile, accept, sketch to revolve. This one. See, can you make out? So I'll give 360, finish. See, this is my profile. With respect to this axis, I have revolved. This is called revolved cutout. So here also, the profile should be closed one. Okay. So profile should not overlap with each other. So next is, in this itself, we have an option called swept protrusion. Swept means with respect to a particular path. Okay. So for that I'll show, I'll take up file, new, a normal part I'll take. Sketch on this plane I'll take, you can take any profile. Okay, it's not about only curve and other things. So I'll take up one curve. See, I've drawn this curve. So along this curve, I have to add a material. Either it may be circle, or it may be rectangle, or it may be triangle, it may be any profile. Okay, that profile should be added along with this path. That's why it's called swept protrusion. So for doing that, I need another profile. Okay, that another profile should be perpendicular to this curve. Another profile should be perpendicular to this curve, or else we have one more option called, go to sketch once again. See, instead of coincident plane, we have plane normal to curve. See here, the plane normal to curve. Select this plane normal to curve. Click on the curve. See, you will get on plane. This move your plane anywhere. This plane will be normal to that curve. Okay, so I'll bring and fix at this end point. So now this is normal to that. You can draw any profile. So simply I'll draw one circle. Don't worry about dimension. You can give your dimensions later. Okay, finish. Next, I want to do this circular protrusion along with this path. That is called swept protrusion. Go to swept protrusion. Okay, single path. So I'm doing this cross section in a single path. Select the single path, give OK. So first thing is, see here, path of the protrusion. So first you have to select the path, give OK. Next, profile on that path. See, finish. So swept protrusion. You have one particular path. Along with that path, you have to do the protrusion. It's called swept protrusion. So or else, say I'll do, instead of taking plane normal to curve, if you want to execute, how can you execute? So I'll take once again a front plane. So I said no, it may be any profile. See, it went somewhere, right? Now this coordinate, the plane is not perpendicular to me. See, here we have an option. If you click on this one, sketch view, it will come to perpendicular to us. Okay, this is another profile I have drawn. Instead of taking plane normal to curve. So now, first I have taken a front plane, right? So now I'll go to return and I'll take my profile plane. Once again, I'll take sketch. I'll take my profile plane. Okay. So take up any profile. It will not move there. Check out. Soft protrusion. Okay. Along the path, accept. Profile. Finish. See. So the two profiles should be perpendicular to each other. If you take up a profile plane or top plane, then you can take it as a front plane as another plane. So consider any two planes which are perpendicular to each other. In one plane profile, in another plane path. That should be maintained for swept protrusion. The profile may be anything. See, I'll go to sketch once again. I'll select this profile plane. Give any profile. Only thing is the profile should be closed one. Okay. Take up trim. See, for trim, if you take up for curve, the entire curve will be selected for trim because it's not an edge. Okay. In previous cases, if you take up the trim for two edges, the intersection point will be retained as it is, only extra thing will be trimmed. Whereas for curve, the entire thing will be removed. Return. Swift protrusion. Single path select. Okay. Path accept. Profile. Finish. All edges selected to be used as a path or a cross section must be connected. Means that the profile is not connected there. Okay. It's a main problem in curve. So we cannot get an exact endpoint on curve. We'll see that. See, it is not connected here. What I'll do, I'll take up line. finish. See now? So if the profile is not closed, it will give an error. Okay. This is regarding soft protrusion. Similarly, we have cutouts. Okay. You have drawn a profile here, right? I'll do a cutout now. See. Soft cutout, lofted cutout, helical cutout. In what manner we are adding the material? In the same manner, we can do the cut also. So what I will do, path will be same. I'll take up sketch, sketching plane as this one. Okay. Same path, we will not change any path. I'll take up circle. Right, because within this profile, we should have a cutout. If you draw cutout somewhere else, if you want to do the cut, we cannot do that. We should have a material to cut. Means already protruded part I have to select. Next I'll go to return. Finish. See here, I'll select swift cutout. Single path cross section, okay. This is a single path, accept. Profile is this circle. And finish. I think you can make out here. So once we add a material, in the same manner we can do the cut also. So that is called swift cutout. Understood? So next is lofted protrusion. So lofted means different polygons to be connected together. Means square, circle, triangle, any irregular shape. If you want to add a material for those things, we use helical or lofted protrusion. So file, new, normal.pr, okay. Sketch. See, for lofted protrusion, the profile should be parallel. The profile should be parallel to each other. So I'll take up a top line. In this, first I'll draw a circle. Circle of diameter 50 I have taken. Okay. I've drawn my circle. I'll return. So next I want a parallel plane. Where I'll get a parallel plane? Finish. See, you can get your parallel planes here also. Or else, if you go to sketch once again, in coincident plane, you'll get a parallel plane here. What's the difference between these two? If you take up a parallel plane in this one, coincident plane or drop down, the plane will be parallel, but the plane will not be visible. Okay, I'll show both. I'll take up this parallel plane here. I want top plane, some 25 mm from the reference plane. Okay, so here I'll draw a rectangle. Return. Finish. See, there is a profile, but plane is not visible. If you want to visibility of a plane, then you have to select it here. Plane, parallel plane, this one. Previous is 25, now I'll give 50. See, this plane is visible. If you want a visible plane, select it here. Or if you just want to draw a profile, select by that one. Sketch. So I'll draw a rectangle. Triangle I'll draw. Okay. You can draw your profiles with respect to dimension. What I'm showing here is how to execute this lofted protrusion. Return. Finish. Parallel plane from this plane. 25 mm. Any profiles you can draw. So circle ಆಯ್ತು, rectangle ಆಯ್ತು, hexagon ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಬರಿಬೋದ್ರಪ್ಪ. ಓಕೆ, ಇನ್ನೊಂದೇ ಸರ್ಕಲ್ ಹಾಕ್ತೀನಿ ಲಾಸ್ಟ್. ಸ್ವಲ್ಪ ದೊಡ್ಡ ಸರ್ಕಲ್ ಆಗುತ್ತೆ. I'll go to return. See, I have 4 profiles here. 4 different profiles. But I want to add a material along with these profiles. Then we have to use lofted protrusion. See, I'll go to lofted protrusion. Select. See, first point, next end point, next end point, this one. Review, finish. See, This is called lofted protrusion. If we are looking from this, only we'll get a C. Understood? This is called lofted protrusion, means different profiles we can add. That is called lofted. Similarly, you can do the cutout. I think you are all now able to do the cutouts, I think. Right? So in the same plane, similarly, we have to draw your profiles. Okay. Sketch this plane. See, the profile should not be bigger than the previous profile what we have drawn. So for cut, I should have a material, right? Return. Next sketch. What we have drawn, triangle here, right? Return. Sketch on this top. You can select the top face as it is. Return. So now see, it is very clumsy, right? We cannot make out which profile is ours. So for that, that's why I have told you to hide the sketches. See, these are my 3 sketches which are required for cutout. Understood? So simply keep all the sketches open. If you didn't hide, it will become clumsy. So that's why once you finish your drawing, adding a material, you have to hide your profiles. So lofted cutout. Same thing. First, second, edge ಬೇರೆ ತಗೊಂತಲ್ಲಿ ಹಂಗಾಗಿ lofted cutout, first one, second one, preview, finish. See, triangle, circle and a circle. Understood? So this is how lofted protrusion and lofted cutout has been done. And next what we have left with, helical protrusion. Helical means in a manner of spring. Okay, that is called helical protrusion. So go to new, solid part, sketch. Okay, so for this also we need to have axis and a profile. For helical protrusion also I need axis and a profile. Okay, so I'll take up a line. Type of the line is axis. I'll give a length of some 100. Click. Next I'll draw my profile. Circle of dia 10. See, it should be a continuous one. Select the profile, go to line, select continuous. Okay, I should have profile and axis of revolve for this. Return. Then I'll select helical protrusion. Okay, once you select helical protrusion, first it will ask for profile to revolve, accept, then axis for revolve. And the starting point of the revolve. So it will ask for pitch. So I have taken already 10 dia. I cannot give less than that. Right? It should be more than that. So instead of 10, I'll give 15. Enter. Review. Finish. Okay. So this is called helical protrusion. So similarly, you can do the cut. Right? So I'll take up a sketch. Sketch on this plane. Profile should be anything. See, I'll take up a rectangle now. So it should not more than the circular diameter. Return helical cutout. Okay. Select from sketch. See, sometimes if you take up coincident plane, see, this sketch will not be selected. That's why always it should be select from sketch, select the profile, accept, right click, select the axis. See, this previous sketch axis will not be taken here because it's for previous profile. So what I have to do? I have to draw my profile here. So I won't draw, just I'll go to include, right? You can include that profile, return. Helical cutout. Select from sketch, select the profile, accept, axis. Axis. Include Atilullah. It is overlapping. Because I have drawn both the profiles in a different plane. So that's why it is not taking. Sketch 1, hide. So now I'll draw the things once again. I'll take up a front plane. Okay. So profile, rectangle, line, axis line, length of 100. Okay. Now I'll return. So now I have my profile and axis. I'll go to helical cutout, select from sketch, select the profile, accept, select the axis, then starting point. So starting point always from the bottom. Pitch, same as previous. How much I have given? 15. Enter, preview, finish. See here, a cut throughout this. So you can make out in a wireframe. This is called helical cutout. Okay. So I think I have showed hole and other things. This much is enough helical cutout. Thread I have shown. And this one, pattern. And we can do the mirror of the components here. So I'll show that one. In sketch also we have done the mirror, right? So here also we can do the mirror. Select smart feature. I'll select this protrusion, accept from this plane. See? The entire entity can be mirrored here. In a sketching also we can do the mirror, where we are mirroring the profiles. Here we are mirroring the entities. Okay. So this is regarding mirror. Better mirror copy, everything is same. So this is regarding cutout and protrusions. So all these things we have shown, hole I have shown, chamfer, fillet I have shown. We are left with only these patterns, circular pattern and rectangular pattern. So I'll show this. So go to new solid part, take sketch, I'll take up front plane. Okay, I'll take up one circle of diameter 150. I'll place it here. It may not be 150. Based on our requirement, I'll simply show the pattern. Return, protrusion, select from sketch, accept. So I'll take up some 10 mm distance. Okay, one side I have taken, I've finished. Select sketch 1, hide. So next what I'll do the sketching. I'll take up sketch here. I'll place my circle. Circle of diameter 10. Okay, I'll place the distance here. From the center to this. $100. Okay, so I drawn and I'll return and I'll do the protrusion of this. I'll do this side of some 25 mm. Okay, so I have one pattern here, one circle pattern. So I want the same feature, means this circular shaft what I have extruded here. I want this same thing in a 100 diameter circle of 12 numbers, 30 numbers, 35 numbers. So you have no need to create all those things. Using patterns, okay, we can do that. Select pattern, select smart feature. Which one? This one. Accept. Where? On this plane. Okay. So once you take up this, see, make sure you have taken a circular pattern. Okay. Radius. So from this center to this center. Next, orientation. From which direction I have to move? Anti-clockwise or clockwise? You can make out there. An arrow is coming out. Okay. I'll click on arrow here. Number of count. So yeah, by default it will be 4. See, 1, 2, 3, 4. Instead of 4, I'll give some 30. Return. See. So 30 will be a higher number. I'll give some overlap ಆಗುತ್ತೆ ಒಂದ್ರ ಮೇಲೆ ಒಂದು. See, this is called circular pattern. So you'll create one feature. The same feature you want it on a profile, a circular pattern, I can do that. Okay, this is circular. Similarly for square. It may not be a protrusion. You can do the cutouts. Don't think only protrusions we cannot. No, cutouts also. So I'll take up top line. So I'll create a rectangle. 100 by 100. Okay. Return. I'll add a material. So some 20. Finish. Select. See, since I have directly taken a protrusion, here it is not showing the profile. I have not taken any sketching profile. Directly I have taken protrusion, I have drawn a rectangle. So that's why in edge bar it is not showing any profile. Then once again sketch on the top of this one. You can draw any profile. It may not be a circle or rectangle. Profile should be closed one, that's it. So I'll draw a rectangle. Sorry. So I've drawn a rectangle, return, protrusion, select from sketch, select the profile, accept some 25 mm. Finish. Okay. So next, I'll go to pattern, select the smart feature. Always you have to select smart feature. So which one is your feature? This one. Accept. On which plane? On top of this one. Which type of pattern? Rectangular pattern. Okay. So I've drawn a rectangle. Number of counts, x-axis to y-axis to. So you can give any numbers. 10, I think here. Some 5 I'll give. 5 in x-axis. 2 instead of 2, I'll give 3. Return. Finish. See? Understood? This is called circular pattern and square pattern methods. We can do the cutout patterns also. Don't think only solid part, no. Protrusion, we can do the cutouts also. Only thing is, while selecting, you have to select a smart feature. That's it. So this is regarding pattern. So I think almost I have covered everything. I have shown protrusion. Then I have shown different types of revolves. Then I have shown cutout, different types of revolve cutout, hole, round and chamfer, pattern, mirror. Everything possible which is required for a basic drawings. Okay, all things I have shown. So using this, you can create any profiles and models. Understood? So in further classes, I'll do the part modelings and assembly. So in next class, we'll do screw jack part modeling and assembly. We'll do that. Okay.